Tell us your name and tell us about your experiment.
I am Clinton Davison, and in 1923 to 1927, Lester Germer and I performed our experiment now called the Davison-Germer experiment. Germer and I designed and built a vacuum-type apparatus for the purpose of measuring the energies of electrons scattered from a metal surface. Electrons from a heated filament were accelerated by a voltage and allowed to strike the surface of nickel metal. The experiment confirmed the hypothesis of Louis de Broglie.
What were you guys trying to do or find?
Like I mentioned, there is a hypothesis advanced by Louis de Broglie in 1924 that was related to wave-particle duality, which was eventually a breakthrough topic in quantum mechanics. According to de Broglie, for all matter and for radiation alike, the energy of the particle was related to the frequency and is associated with wave by Planck's relation.
Where did the experiment occur?
We did the experiment at the Western Electric Engineering Department, which is what it was called at the time. In the 21st century, I believe people call it Nokia Bell Labs. It is located in New York City, New York.
What other significant events were happening around the world at that time?
On January 1st, 1923, Model T Ford came out with the first affordable car. On January 1st, 1927, Babe Ruth became the first player to hit 60 home runs. And on May 20th, 1926, Air Commerce Act is passed, providing aid and assistance to the airline industry.
Who else was involved in this project?
An important contribution to the experiment was made by Walter Elsasser in Germany during the 1920s. He remarked that the wave-like nature of matter might be investigated by electron scattering experiments on crystalline solids. This suggestion of Elsasser was then communicated by his senior colleagues, Max Born, to then physicists in England. When our experiment was performed, the results of the experiment were explained by Elsasser's proposition. However, the initial intention of the experiment was not to confirm the de Broglie hypothesis, but rather to study the surface of nickel.
What was your role in the project?
I began work in 1921 to study electron bombardment and secondary electron emissions. On a break, I attended the Oxford meeting of the British Association for the Advancement of Science in summer 1926. At this meeting, I learned of the recent advances in quantum mechanics. To my surprise, Max Born gave a lecture that used diffraction curves from my 1923 research, using the data as confirmation to the de Broglie hypothesis. I learned that in prior years, other scientists had attempted similar diffraction experiments but were unable to generate low enough vacuums or detect the low-intensity beams needed. Returning to the United States, I made modifications to the tube design and detector mounting, adding azimuth and collatitude. Following experiments generated a strong signal peak of 65 volts and an angle of 45 degrees. I published a note to Nature magazine titled "The Scattering of Electron by a Single Crystal of Nickel." So although electron energy diffraction does not follow the Bragg law, it does confirm de Broglie's equation. Our accidental discovery of the diffraction of electrons was the first direct evidence confirming de Broglie's hypothesis that particles can have wave properties as well. My attention to detail, resources for conducting basic research, the expertise of colleagues, and luck all contributed to the experimental success.
What impact did your project have on the physics community?
Our experiment demonstrated the wave nature of the electron, confirming the earlier hypothesis of de Broglie, putting wave-particle duality on a firm experimental footing. It represented a major step forward in the development of quantum mechanics. This was the first application to particle wave. My partner Germer and I had just proven one of the underlying principles of quantum mechanics.
Did you happen to receive any rewards for any of your discoveries?
Yes, I received the Nobel Prize for Physics in 1937 for experimental discovery of the interference phenomenon arising when crystals are exposed to electronic beams.
Thank you so much. We enjoyed your work.
Thank you.